That's the first time I've ever given a talk at a Drupal camp where I remember to hit the button first. Ever. Thanks, Avi. I'm Dwayne, and we're here hopefully to learn Git in the last session of Bad Camp 2018. So I work at Pantheon, talk about them in a second. I like to do stuff outside of tech, karaoke, for those of you that went to the Drupal karaoke. There's actually Drupal karaoke happening tonight that I'm not going to, unfortunately, over at the Jaguar. If you're interested in that, find that on the internet, on Twitter. Twitter's the best way to get a hold of me in the world. I love Twitter a lot. In fact, I got a project, Twitter related, but I talk a lot at camps and stuff. So someone take a picture of me in front of this picture. This is going to be interesting because it's a small screen. The next, like, we do it porch or landscape. That help me out. And tweet this at me. See what are they doing now? Someone telling me this way.
They're already myself. Nice.
This is my Inception project. This is like this is picture like 24 this year. All right, thanks for that. Paying attention to that nonsense. So Pantheon. Anybody here not know Pantheon? Okay, we'll skip then. But I don't know who's in the room. Like, you came to the last session of Bad Camp for a reason, and came to this session. So who's here? Like, who's a designer? Awesome. Anybody consider yourself a full-time developer? Awesome. Any project managers? Any content creators who write content? This is actually designed for content creators. This entire deck, because that's how I first understood and came to learn Git. So hopefully you'll get out of it. Anybody doing something different? Business owners? Anything else I didn't say that it's notable? Student? That's an awesome place to be because Git's for everyone. So why on earth would we want to learn Git? We keep being told it's important. If you saw Michael Hess's session today, Drupal.org is going to merge up with GitLab and do all sorts of interesting, fun things for the future. So knowing Git is super important for that sort of stuff, but just at a base level, let's completely forget about Drupal. I know it's a weird thing to say at Bad Camp, but just how many people have ever been in this situation where they've like renamed doc and you rename a doc and you rename a doc? Yeah, this is a horrible situation to live in because what's the final? And collaboratively, if we're working with other people, who wins in this situation? Yellow or blue? Blue. And what happens to yellow's commits? Or changes. They're just gone.
It depends how fast the computer syncs.
Yeah, it depends on how fast the computer syncs. You're absolutely right. But in Dropbox, it just goes away. Google Docs is actually a little bit better at this because you have version control built into that a little tiny bit. But then who's ever seen this screen? My screen of death? Yeah. We've all done something like, okay, my entire install doesn't work anymore. But ultimately, like, there's a really great tactic of just undo. Has anybody ever hit undo all the way back to the beginning of a project? Yeah. It's a great tactic. It's a terrible strategy long term. But it's nice if, oh man, the last two lines are terribly wrong. Just Control Command Z. But this is the set of problems that Git was intended to solve. Like, how do we collaborate together in a way that's coherent, scalable, and fast? So Git itself, if you go to Wikipedia, it will give you an answer like this. Key to here is like very large projects, because that's what it was born out of. Git was born out of the raw necessity of Linux community having to collaborate around the world. A couple thousand developers in 2005, like, how do we source control this thing in a sane way? And so Linus scratched his head and said, Junio, what do you think? What if we gave everyone a local copy of everything? And that was kind of how it started. And my favorite quote from Linus Torvald is, the smartest decision I ever made was giving Junio the project. He still maintains Git, like the actual Git repos, like for Git itself. But that's why it started. Like, there's thousands of developers had to do something seriously, it's not complex, very distributed, in a very efficient manner. So what they said is, let's abstract this away from the concept of development. And they introduced the concept of knowledge worker. They didn't introduce this concept to the world. Like, this was a known concept well before they started using the term. But they said, let's build something for people that work inside documents. At the end of the day, Drupal, WordPress, Laravel, all of it is just PHP manipulating strings. In the Node world, it's Node manipulating strings, or JavaScript manipulating strings. But it's just piles of docs that do a thing. But the basic idea of Git really comes down to this. You make a document, you save a document. You edit that document, and you save those changes to that document again. But when we saved it, we're going to track the modifications, what changed between those states every time you saved, and give you, the author, a chance to explain yourself, what exactly you did. And that's one of the superpowers of Git. And we'll get to that. But being able to see exactly what happened in history is super important. Because really we're talking about entire projects. Same even with single document. Google Docs isn't actually bad at that. If it's just a single document. Again, I'm talking more to the content creators in the world than anyone else. Version control is pretty good. You can see your version history. But if you have 20 Google documents, nope. That is just impossible to figure out what happened between those documents. For something as complex as Drupal, wow, yeah, that we're talking about a lot of files that get modified over time. I almost took out the entire rest of the slides and just used this one to explain the rest of my talk, because this is it. This is all you need to know about Git, right here. And this is what we're going to cover today. We go forward in time, we go backwards in time, you can branch out to parallel universes, and those parallel universes can affect our main universe timeline. This will all make sense by the end. Even the point, kill grandpa, those are merge conflicts, and we'll get to that. That'll be funny later.
Yeah, that's the best episode of Voyager, I imagine.
Yeah.
Yep. Time paradoxes?
A lot of time paradoxes.
Oh.
The hardest concept for me to wrap my head around when I was first learning Git, and the raw power of why Git can do what it can do globally and why it's used in so many complex projects, is this idea that everything is local. If you have cloned a project, if you have a Git project you have access to, you have the entire project. There are ways to chop that up. We're not going to get into like submodules or how to vary repos, and we're not going to think about Composer or anything like that today. We're just thinking about raw, generic Git repos. Everything's local. The idea of a Git server is just a server that has Git on it. There's no such thing as a central Git server. It doesn't really make sense. There's servers that you can say, this has Git on it, and me as a human being, I am treating this, and my team is treating this as the canonical source of truth. But Git doesn't know. Git is local. To that machine, to that machine, to that machine, to that machine, to this machine. It's just local. It knows that it exists. And it knows that there's other versions of it that exist. But those are just local copies. Git is exceptionally lightweight. Who likes using SFTP to get entire documents up and down? Nobody. Nobody likes SFTP. It's slow. It's great for what it is, but it's just slow. So if I have a 10K document and I need to change 2 characters on SFTP, I have to move 10K across the wire every time I change, or 10 meg, or whatever big I said that file was. It's the end of the day. But I have to move the whole thing. If I'm doing it with Git, and I change 2 characters in a 10K file, I move 2 characters across the wire. Super, super, super lightweight. And all the meta of tracking what we did is super lightweight as well. Git, however, is not a backup tool. One of the nice things about Git is the version control for your code. And this is mostly, I wrote this for the WordPress community, to be honest with you. A lot of people in WordPress are still coming to terms with the fact that it's a CMS, and that there's a database and a file system at play that you're not tracking. There's your code, there's files, and there's a database. So you need to back up everything. But you all know that. Backing up is good. But Git itself is not backing up your database. It's not backing up anything it's not tracking. So you have to say, Git, actually pay attention to this if you want it to have a history for you. And this is the best documented project in the history of the world as far as I can tell. There are thousands and thousands and thousands of pages of documents. There are more tutorials than you can, like Google can show you in a day. It is just an absurd amount of resources out there to learn Git. So why did I write an entire talk and very passionate about getting people to use Git? There are a lot of documented resources. There's a lot of tutorials and whatnot, but there is a hurdle I find to Git that it's kind of this black box of like, what's going on here? What are we doing? People tell me to do this, and I got these like 5 commands that they told me to do, but conceptually it's like, it's a black box. And so hopefully by the end of today, if you don't know Git already, if you don't have Git installed on your machines, so those of you who don't have your machines open, the way you're going to get the most out of today's talk is open up your machines and play along at home. And if not, don't worry. All these slides are available online on the website mcdwayne.com, and they have all the things I'm going to show if you want to play along later. But today's more about getting the general concepts down. So if you've never installed Git locally, if you have OS X or Linux, it's probably there. Just go open a command line terminal and type Git, and if it says, I don't know what Git is, or like Git command not found, go download it, git-csm.com. Source Control Management is what CSM stands for. And it's free, and it's really lightweight. You can pull it down. And then you can play along at home. I'm going to talk about the CLI. That's how it was invented. It was invented as a command line tool. If you really don't like command line tools, or you're not really comfortable working with the command line, Git is actually a really great way to get the basics down and get used to working in a command line environment. But there are a ton of awesome resources and tools to give you GUIs for everything. The one that I use, if I ever do use GUIs, is SourceTree, but they all work. It's just doing the command line stuff for you in a GUI. Git Tower is this one, and a lot of people swear by that. Some of these include tools that Git itself doesn't give you. There's a little bit of a logic layer inside of SourceTree that can unstick things if things get stuck. We'll talk about that later. But none of these are needed. If you download Git and install it, you can use the command line. So the very first thing you do, if you are going to start a brand new project, is go make a directory, move in that directory, create something, a file or not, and we do a git init. And git init, I know this is really hard to see up here. This is meant to be seen at home later when you're studying it, so don't worry about the actual output of this thing. Because what you do is you're creating git init. Git init creates a file, and that file looks like this, a .git. So the dot means it's invisible, or it's a hidden folder. So it just doesn't show up unless you're looking at hidden folders. The contents of this, the dirty secret of Git is it's just using basic file system commands. It's not doing anything like crazy or unique to like a weird programming dynamic or anything. It's just really advanced local file system management with a couple little special pieces. One of the special pieces is called a hash, and can algorithmically give IDs to things. We'll talk about that later. But that's all stored in here. Head is where you're at. So that's the vision of reality that Git is tracking. That's like, this is the world that we live in. Everything else lives in branches and folders. I'm not going to talk about the true structure of Git today. That gets a little overwhelming, but it's really fascinating to go learn. The idea of the tree, the branch, the node, the blob. These are all buzzwords, but inside of here is tracking everything you do over time. But you don't have to worry about that. You just got to know the basic Git commands. Git init just gives you a folder that does this. So this is like starting from scratch. There's a command you can run anytime you feel like it, no matter what time of day it is, no matter what you think you're doing in your project, and it's always safe, it's always awesome. Git status. Git status says, what does reality look like right now at this point in time? It's a read-only, and it looks like this. Oh. Again, this is really hard to read with the screens and the lights. But Git status says, hey, I'm tracking status. I got an initial commit that happened, and there's a bunch of files that I'm not paying attention to. They're in red. That means like, I see these files, but should I pay attention to them? I don't know. Git's really smart and Git's really stupid at the same time. Like, I see these things. I could track them if you want me to, but you tell me. So it even tells what to do. Git add right there. But we'll get to that. Git status is just a good thing to run. So if you just installed Git, you just Git initialized, run a Git status, and it will tell you, hey, this is what the world looks like to me. You can run it anytime you feel like. And now is the heart of the talk. 90+% of what you do with Git is this. There's this idea of working directory. So, who here doesn't use a command line on the day-to-day? Anybody here like brand new? Okay, awesome. There's an idea in the command line world called present working directory, PWD. So if I am in a file system, I think it's a little bigger. I'm on my terminal, and I do an ls. That's all the content of this folder, and if I do a pwd, that's the present working directory. I'm in my /user/Dwayne/document/kevinthal.com folder. It was an open source project. We'll get back to that. So that present working directory, wrong way, is my working directory. It's what I see. It's like what this project, everything in that folder and everything underneath that folder, all the subfolders from there, that's my working directory. So if we imagine that this podium is my present working directory, I can say, all right, git add. I want a snapshot of how this is right now at this point in time, and I want Git to remember this for a minute. Like, hey, remember everything as it is right now. And since we're talking about documents, it's literally just making a copy of it. It's like, all right, this copy of this world at this point in time, I know what this looks like. It's almost like I'm taking everything here and putting it in a file folder. I'm like, all right, I have this in a file folder now. And if nothing changes, I want this to stay like this for a while. I want to remember this. I'm going to then commit it. I'm going to write on the outside of that file folder in magic marker exactly what's in it and why I put it there and why I wanted it in that state. And then I'm going to put it in a big old filing cabinet, which is going to remember all of my commits throughout history. So most of the time when you're working, it's like, all right, I've got it like this. I'm git added it in this state. And yeah, you know what? That's what I want to commit. This is the version of reality I want to work with in the future. Git commit, and now we have this version of reality. Then I keep working on it. I'm like, I don't need this pen anymore, but I'll take this thing over here, and I'm not going to touch the mic. I'll move this, and then I'll just adjust the whole thing over here. All right, git add. I'm going to take a version of this, exactly as it is. And yeah, I want to keep working with that for a longer period of time. So git commit this, and then that's in that file directory, or that file cabinet. So anytime in the future, I can go back and say, well, what was the other version of that I had before? Let's look at that commit. Oh, that wasn't there, that was there, and that was there. Okay, that's the version of reality I want to work with again. All right, let's go back to where it was before, or it was in that last commit. All right, that's the general idea of Git. I take a snapshot of what's in a place in time and store that long term. Git add, hey, Git, actually pay attention to what's going on right this minute. Git commit, let's track it long term. If you can walk out of the room with these two concepts in your head, that's 90% of Git. And this is the idea of moving forward in time. Other way to think about this that helps some people is think about a number line, a number graph. We all remember number graphs from 4th grade. It's like you got 0, 1, 2, 3, 4. Like literally nodes on a line, like circles on a graph. Moving forward in time, from your point of view, we're moving forward in time. 1, 2, 3, 4, 5. It's like, all right, at 1, that's my initial commit. And now I've like git added, git committed. Now that's 2. Then I can move forward in time along this node. That's actually how Git is conceived on whiteboards. And you'll see a lot of tools. If you're on your computer, look up a Git graph. You'll see all sorts of wonderful graphs of like intersecting lines and dots and charts. And it's a graphical based system. Everything is conceptually very simple from points on a number line. A lot of documentation actually shows you these graphs. But for this one, it's very straightforward shot. We can add individual files. Again, this is more for your home use when you're learning this on your own. The only way you're going to learn all of this stuff is actually going and doing it over and over and over again. So you add a file, and now when you do a git status against that file, it's like, hey, I'm tracking that one, but I'm still not tracking these. Or you can say git dot, git add dot. Git add dot is your standard or your present working directory. It's like everything that's changed, everything you see, just add the whole thing. The best hygiene practice is only track what you need to track and only add what you need to add and commit, off of that. Or if you're like me, I just commit the whole thing because that's what I do. I add, and now they're all tracked. And then we commit. Commit's got a special flag to it, and you're like, wow, flag's right off the bat. This is the only one I'm really gonna force on you. Commit, git commit, -m, and then a message. The message you want to write for the future self. This is where being very verbose and very specific about what you did is going to come in really handy. So back in 2005, if someone working in, India has committed something to the Git system itself, and he wants to share that with Linus and the rest of the team that's working in Sweden, or who was living in 2005. Anybody knows? Anyway, Northern Europe at the time. They can go in there and just simply read the message of oh, that's exactly why they did what they did and exactly what they changed, and now I know what to do next. So writing messages. And you can go back and look at your own messages. We'll look at that in a second. But that's what this looks like. You git commit, and in quotes you just say what you did. And you just write long term. If you leave out that -m, it drops you into your default editor, and unless you have done something special to your machine, you're going to get dropped into VI. VI is the universal, ubiquitous, Linux, awesome editing program that works in almost every terminal in the universe. It's really hard to use. The number one thing Googled on Stack Overflow to this day is how do I quit VI? True story. So if you get stuck, if you get to a point, remember, I to insert, then escape, :WQ. Because :WQ to write quit is the most intuitive thing ever. Actually, if you get good at VI, it's really fast. Some people really love it. Anyway. And then you just repeat this process forever. And I know this sounds like I'm repeating myself and ad nauseum here, but again, this is 90% of what you do with Git. You git add, you git commit. You git add, you git commit. And you just build this chain over time of this is how this project got built. And you can go back and look at this at any point in time. Git log is the other, there's two commands you can run at any point in time and be okay. Git status and git log. If you just run git log, I'll just do this real quick. Git log. It shows you a bunch of information. It's all right, here is this full-on hash number. So this crazy long number, it's more than 1 in 3 billion chance that you'll get the same number in the same project. It's never happened in all of history in the wild. They forced it in the lab once, but they had to do some special trickery to force that to happen. And that's the magic of Git. The magic secret sauce is this hashing algorithm that makes commits very, 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 very unique. It shows you the author, the date, what they did, their commit message. So it was fun. Just keep scrolling. There's also another version of this you can run, and that's what I had on the slide, one line. So I don't like doing Git logs like this because it gets a little messy. So I alias git log one line is just GL on my machine. I'm not gonna type it out. But git log one line gives you all this. It's the exact same thing, it's just shorter. And instead of that crazy long number, you get this small hash. And those, inside of the project, are the same as the super long hash. So Git knows, well, that number means that stupid long number. And you can use them interchangeably. So this is the entire history of my project with kevinthal.com. I was at Drupal GovCon, and I bought kevinthal.com because he hadn't bought it yet, and turned it into a fun little website project that I have a GitHub page on. Anyway, this is, saw JD Flynn did the last 2 pull requests today. But that's the real power here. We can go at any point in time and see who has been working on what and what we've done. Even if you're working locally by yourself, this becomes super handy to see where things got introduced, where things got put in, and if okay, everything was hinged on this thing that we got wrong back 5 commits. You can just, that's what we'll talk about next, is getting back and just undoing that thing, and then building back off from there. But This is only as good as you make it. So your Git log depends on you making good commit messages. So err on the side of too verbose, and it will help you a great deal. It'll actually help with your documentation as well, if you get really, really verbose with it. You can also see what changed from the last time you committed to what you changed locally. It's called git diff. We should probably all be familiar with diffs in general if you've ever committed or contributed to Drupal, because the diff files are how we tell what's in a patch. The git diff says, what's different? And I know, man, it's really, really hard to see on the screen. There's a red line here that says minus hello world and a plus hello world, and then there's a new change below it. For whatever reason, and there's serious reasons behind this, we're not going to get into them today, Git doesn't understand the concept of I just changed this one thing inside of a line. It's like, no, you took the entire line away, and you added this whole other line, but there's only one thing different. And that's just how it works. So it's like, you took this away, and it gave me this. That's the difference it sees. So git diff is another one of your best friends. If you've already added something, you git added it, you can git diff staged, and it will show you the difference between what got committed last and what you've staged to commit next. It gets a little overwhelming. Don't worry. You won't use git diff probably a whole lot in the very first time you start using this stuff, but it becomes really handy when you're collaborating. Figure out what has changed inside of a folder or a project. So that's forward in time. Forward in time. We've added things, we've committed them, and then we've looked back into history and see, like, this is everything we've done. Just like quantum mechanics, like, there's no reason time has to move forward. We can move backwards just as easily. It's up to you. So I'm going to talk about two specific things to do in Git. One of them very, very safe. The other kind of dangerous, and you shouldn't do it without consulting your team. Git revert. If we go back and think about the number tree, that number line, 0, 1, 2, 3, 4, 5. If you want to step back to 4, how you do that is you tell Git, revert everything we just did in 4. And what you actually become is a step forward, so you're on node 6 on the number line, but it's subtracted what was done in 4. So you're reverting to the code that was there before. So it's like, from a code perspective, it's like we took a giant step backwards. But from Git remembering this stuff, it's like, no, I'm going to undo all of that stuff, but that undoing becomes its own commit into itself. I know that's really hard to read from the back. That's the basic idea. We can revert back. So we can revert back one commit at a time very safely. It's basically the undo button on steroids. So if I'm like 10 commits in and on commit 5, I mess something up big time. And I've used that as a building block for all my commits since then. And I was just conceptually wrong and I need to undo that. I will just revert back through the chain, do 5 reverts back, and I'll go back to the state that was before I made that mistake and go from there. It's a very, very, very safe way to do things. Just, yeah.
So if you do commit 1, 2, 3, 4, and 5, and you like the stuff you did in 4 and 5, but you don't like what you did in 3.
It depends. You can revert anything in the tree. But if you built on top of that, now you're in a state where Git doesn't know what to do. And we'll get to Git merge conflicts in a bit when I get to merges, and we'll talk about that scenario. But if you revert like back to what you did, it's very safe. Just go and say, just revert that. Git gets to a point, it's called an attached head. And it's one of those dreaded things when you start out. It's not that scary of a scenario. Remember when we looked at that file folder earlier, there was a thing called head? It simply means Git's not 100% sure where you want to point head inside of all the files. That's what a detached head is. It's like, I'm not 100% sure where I'm supposed to be pointing. All you got to do is tell it where to point, and it points there and you're fine. If you made changes inside of the same folder, inside of the same file, and you reverted and you say, all right, take commit 2 away. But commit 2 like takes away some functional, takes away things that are dependent inside the file, not from a code running perspective, but from like, if that code wasn't there, we wouldn't have modified the code in 3 and 4.
So the question was really this command, git revert,
Yeah.
and give it a hash.
Yeah. It will undo that, whatever was in that commit.
Could
As
I
the next
do it
commit.
for just 3?
Yeah.
Okay.
But you might get to a point where you'll probably get to a point where Git's confused
The
about
normal way is to git
Git
revert.
Git revert back.
And it just
Yeah.
goes, but does it leave 4 and 5? I mean, assuming there are no conflicts.
Assuming there are no conflicts, yeah, you should be fine.
Okay.
Assuming there are no conflicts anywhere. If you're working in a bunch of files, yeah, that's probably not going to be. If you've like put in a new module and you want to take that module back out, you could just revert that out. Or you could just take the module back out and then make a new commit forward, which is probably the safer thing to do. But this is the way of like, I've deployed something, oh no, we need to get it back to the state right before, but I don't want to touch my database again. Just revert it back. You can even revert reverts, because revert is just a commit. So if you reverted something, like I shouldn't have reverted that, you can just revert that revert, and it goes back to the state it was before. So conceptually, you can just move back in time, and then step forward in time, back in time, back and forth. The other thing I'll talk about, which is super dangerous, and you should only do if you really know what you're doing, is reset hard. Reset hard says, hey, let's go back in time and forget everything after the point I said forget. So here I've said, let's revert back to 3, 4, 5, which is this one, which where I made a revert to make a 4th change. I'm going to reset hard on 9.2, sorry. I was reverting back and I reset hard to 9.2. Now I'm back at 9.2 as the 3rd change, and all the rest of my history is just gone. Like I've literally reset history back to a point, and everything after that is just, does not remember it. Now, Git actually remembers it. Git doesn't forget anything. Under the covers inside that folder, all of these commits will exist for the entire history of the project, but they're buried. You can't see them in your normal history. You could actually go get them. But that's way advanced. I've never actually done that.
So hard's actually soft.
What?
Hard's actually soft on the inside.
Yeah. What? Sorry. End of the day, man. All right. That's forward and backwards in time. Like we have a system where I can make a bunch of changes, save them, write down like why I made those changes, and keep doing that forward in time. That's 90% of what you do. Reverting back is actually not that common. It's way more common to do things forward instead of going back and reverting things. Reverts, normally are let's fix the last thing that we just did. But then we get to this really crazy superpower that Linus and Nuno thought up. Like, what if we could just take all of our code and say, here's an exact copy of that code that's meaningfully connected to that original version of the code, and do everything we want over there, and only when we want to merge those changes that we put in that branch back in, well, it only affects the master branch when we do that. By default, the baseline reality that you're working in is called the master branch. If you have no other branches, it's called master. That's just default. They had to call it something. It's kind of a bad name. It's nice because it's consistent and we know that it means the main timeline, but it's just a branch. It's just a version of reality. You got as many versions of reality as you want. Making new branches is simply saying git branch and then naming the new branch. If you just say git branch with nothing else, Git just shows you what branches you got to do. If you say git branch and then name a branch, it's like, all right, now I got a new branch I just made. So if I say branch again, now there's a new branch. Now it's a parallel universe I can go play in. That is exceedingly powerful. So if you're working on something and it's like, I want to experiment, what would happen if I injected this function? Git branch, flip to that new branch, git checkout. Checkout is how you check out a branch. And now we work in this new reality. And it doesn't affect your master reality at all. We're just working in a separate reality. Git checkout actually does something really magical feeling as well. It's not really that magical. But inside that folder, there's this thing called head, which says this is the version of reality. This is what we're pointing at. This is where it kind of gets a little meta. Git is pointing at what reality is. It also is controlling what that reality is at the exact same time. It's saying, here's my present working directory. If I check out, it says move the head so it points at whatever I'm pointing it at. So if I say check out this other branch, and inside that other branch, I had done all this other stuff to my working directory. It's like, now that's reality. Now inside of my present working directory, all my files are still there, but the contents of those files have shifted to this reality now. Because in that reality, in this branch, this is real. This is what's going on. But as soon as I check master back out, I'm right back to where I left off. If I make these changes over here, it's like I'm going to add that, I'm going to move this around, move that. Okay, now this is great. I've committed this. This is exactly what I wanted. I know why I did it. And I want to finally reflect it in the master branch. This is a long-running example. When you review this at home, like it shows exactly what this should look like. When I want to merge it back in, I merge it back in. Branching, merging. Branch, that's create a new reality. Merge, that's merge those back together and make that one reality again. Now my branch itself doesn't die, it doesn't go away, it doesn't clean up after itself. It's like, all right, all the changes I made in this branch, let's just pull those down into this master branch, and that's the main reality we're dealing with. Works the other way too. Again, master is just the name of a branch. So if you're working on your Drupal site and you do an update, in your main branch against a live site can be terrifying, but why not create a new branch and go try it over there? And if it works all beautifully, hey, let's just merge that to master. But what if you're working in a branch on some feature and you're like, well, I can't update this yet, I'm in the middle of the heads down on it, but let's merge, let's update master, get this to production because it's Drupal-geddon, and then we need to merge those changes over to that branch we're working in. You just merge that branch of master into the branch that you're working in. So merging works between any of these parallel universes. You can merge from anywhere. And you can also branch from other branches. So master, again, is a misleading word. Conceptually, it's very simple to think of like main reality and all these branches off of it, but it's just itself a branch. It's kind of fun to think about. That's where most people run into this idea of merge conflicts when you're merging things back together. Merge conflicts are basically, I have changed the exact same file in two different branches in a way that Git can't figure out what to do. And it's going to say, I am not sure which is the proper head. What is it that you want me to do here? Git gets to a point where it gets confused and it just stops. It's like, all right, I don't know, error. And what it will do for you, and this is a very trivial example, and I wish all merge conflicts were this simple. It will say, all right, here's what is looking at in your master branch in the head. The last time I knew what was going on in reality, this is the thing you said to do. And this branch you're working in, you said do this. Which is it? So it's up to you to go in and actually fix it. Go in and actually say, all right, go in and that line shouldn't be there, that line shouldn't be there, and that line shouldn't be there, and that line, okay, this is what reality should look like. And then I git add, and then I git commit, and I fix my merge conflict. Merge conflicts mean a human being needs to be involved to make a decision about how things should be working, which is the proper reality. So they're not really bad, but they're gonna really suck a lot of your time and energy if you're not careful around good hygiene. That's what code reviews. If you're working on a large team, code reviews are worth their weight in gold. Understanding what this code will do when we merge it in with someone else's code. Because we've read it line by line and know that, oh, that's going to cause a conflict, that's going to cause a conflict, that's going to cause a conflict. But conflicts are at the end of the world. There's a lot of tools out there to help you with this stuff. In fact, if you type git merge tool, it will say, hey, you should probably install one of these things. There's a bunch, but these are the ones I'm recommending. You just can install it and go to town. Or this is where I open up source tree. When I hit a merge conflict that I can't figure out on my own, I'll open up source tree. And source tree has this layer of logic above Git that makes decisions. It's like, oh, you probably meant this. You probably meant that. That's not native to Git. It's just, a cool tool. There's a lot of tools to help you figure this stuff out. So far we got through moving forward in time, moving backwards in time, and then branching out to these parallel universes, and then merging them back in. Hopefully I haven't lost anybody. Or if you're completely lost, you're faking it well. So remember how I said everything's local? The last big concept to talk about, like there's 4 big concepts, is working with repositories on machines you don't personally own, or you have access to. And those are called remote repositories. GitHub, GitLab, Bitbucket, all of the other clones out there in the world that exist that I'm not going to mention, because this is like 97% of the market. These are just Git repos on someone else's machine with a GUI around it. It's kind of all there is. Like it's Git and a whole bunch of other services built around it. Like GitLab has this entire CI system, continuous integration delivery system with their workers that has nothing to do with Git. It's just a cool service they built around Git. But Git is like the core to making all that work. Git add, Git commit, they work on all these. Git merge works on all these. This is just this repository you don't own. Here's GitHub's interface. Pretty cool looking. It's got a lot of functionality that they built in with their settings and whatnot. But the basic idea is this. GitHub, GitLab, doesn't matter. It doesn't even need to be one of those services. It could just be someone else's machine that you have access to over the network. This is where I'm going to go back and say it again. Everything is local to Git. Even though there are 3 repositories here, each of them thinks it's the only repository that matters because it's the local repository in charge. It thinks this. It really does. But there's this concept of remote. Remote where you say, hey, Git, here's an address of a clone of you. Your job is to make sure that you are in sync and that it's an exact clone. So keep track of that. But at no point does any Git repo think it's the master repo. The idea of like an origin, the idea of which is one in charge, that's a human layer of logic. This one thinks it's in charge, this one thinks it's in charge, and this one thinks it's in charge. You can push or pull changes between any of them. In fact, Git pull, it's way easier to think of all of the changes that happen across the wire if you think of what is the repo on the machine that I want to affect doing from its point of view. It's pulling things into it. Or if I'm working on my machine and I want to push something to your machine, I can literally git push that thing to you. And if you have it set up permissions to let me just push things, it will just push it in. Or you can say from your machine, hey, I want to pull that from your machine because we're no longer in sync. Origin, just like master, is just the name of the main branch, the main remote repository that gets set up by default. That's just the name they picked, origin. They could have called it Charlie Brown, but they called it origin. It's a good name. So inside of your Git repository that we made earlier with a init, that we've done some things, added some things, we can add remote repositories. We can say, hey, here's this address on GitHub. So git remote add origin, and here's the address on GitHub where now this is a remote GitHub that a remote Git instance that you need to be a clone of, or you're going to be a clone of it. And now if we have just the permission set,
You can have 2 remotes?
you can have as many remotes as you want. You can have 100 if you want. Like, again, there's no, origin is just the original name. You could have one called origin, you can have one called Pantheon, you can have one called Acquia, you can have one called Platform
What if they're
SH.
different from each other? The 2 remotes that you're tracking, they're different from each other.
Then they won't be in sync. And it's your job to figure out which one of them is in charge and which one should be the one that you're syncing from. So if you are working locally, this is the classic example that we see at working at Pantheon. I'm working locally, and I want to push all of my changes up to GitHub first. We push to GitHub. Now that is where we're tracking everything. And let's say we're doing a Drupal 8 site with Composer. We're just only pushing to that repo our custom code. So we have it all set up with our custom repo with Composer. Now we need to build that. Again, we'll pull the whole thing locally. We'll do a build step and push that code that it builds into another repository. Pantheon in this case. That's a very advanced use case for way out of the side we're talking here, but that's what you'll run into the fastest inside of Drupal 8 world. More likely, I've got my stuff on my local remote or my local machine. I do my changes. I'm going to push it up to my dev server. And every time I want to push to my dev server, I want a backup of that Git repo somewhere else. So let's just dual remote what's there and say, okay, there's this other remote, so I'm going to push to my dev server and also push to GitHub. That's a very common use case as well. And it's still you, the person in charge of the repository, saying, yes, I'm in charge. We'll get to it in just a second, this idea of ownership and who's in charge of these repositories. But if you're doing this all yourself, against your own GitHub repository and all your permissions are just set up correctly by default, you can just push and pull to anything you want without any restrictions. I can push it over there, I can pull it over here, and you decide what's true. Git doesn't know. It just knows that it needs to be in sync. It wants to be in sync. Git push, yeah, I already talked about that. Pulling. So if you go through the slides later, this just walks through an example of pushing and pulling and pushing. It loops through, so that's why they copy and repeat themselves. So that's for playing along at home later. But now that we have a master or a remote repository set up, it's literally okay, I'm taking the changes over here, and I want those changes to be reflected in this repository, and this repository, which are all clones of this repository. It's up to you to pull them or push them to the proper places. In fact,
okay, if you have two remotes set up and you do git push, how does it know which one to push?
Because this is incomplete. Git push is the base command. I also have to tell it what branch and what destination I want it to hit. Actually, what destination and what branch. So what you see in here, actually let me go back up a couple slides. That's a very, very, very observant question that I skipped. Git push origin master. -u says it's the first time I'm pushing there. It's a GitHub specific, not specific thing, but it's a GitHub thing. It'll throw you that. But git push origin. Origin is just the default name of the first remote that you add. Again, you can call it Charlie Brown. Say git push Charlie Brown, and masters. Again, the main logic branch of reality that we're in. But that could be a new branch, feature branch. Because it's just another copy of Git. It's got all your branches over here too. So you can say, I just want to push this on this branch. And we won't affect master at all. So the full command is git push origin master most of the time. Or git push the destination remote and what branch you actually want to push over that you're committed. So good question. I probably should restructure this slide based on that feedback. But you can see this if you go through there. So git push, git pull, same thing. Git pull, which remote you want to pull from, what branch you want to pull from. But most of the time you're not going to manually add remotes. The vast majority of the time, that is taken care of you with this awesome, multiple steps combined into one awesome command called clone. So who's ever gotten an address for hey, go look at my repository over here? What you're supposed to do most of the time is just git clone that down locally, and then you can start working on that code. And you have a connection to that remote repository. So if you want to contribute back to that, whoever you cloned it from, there's a path for that. If it's just your code, and you clone down locally, and things are going horribly wrong, you accidentally deleted that folder, or you on purpose deleted that folder for specific reasons, it's oh, well, I'll go back to where I left off, where the project was last saved on Git, or GitHub, go to GitHub, git clone it back down, and I'm right back to where I left off, no matter what machine I'm on. I use GitHub a lot for backing things up personally, to a point of, never turned that off today. Off. All right, I use, that threw me off. I use this for my projects a lot where, anyway, I lost my train of thought. Let's figure that off. The git clone does all the steps of git. That's set the git remote repository, create the repository locally, fetch all the local, or fetch everything across the wire, and then put us in sync automatically from the first go. So, move into a document folder, say git clone this repo, and that big button, and now it's pulling. Nope, this one, that line, git clone, and it pulls down and makes me a repo, and it's really, really fast. And that's how it gets code from one point to another. So that's what I was gonna say. If you own it all, like just pushing it back up is super easy, and that's how you're gonna start committing things on repos you own without any question or thought. It's just push it up, pull it down. Oh, that's what I was gonna say. I back up a lot of things on my machine on GitHub, and if this machine like dies, I'm not worried. I have LastPass, I have GitHub, my bash aliases are all in GitHub and private repos. A lot of my personal work's in private repos. And this machine dies, 10 minutes later on a brand new install, I can just get to GitHub, clone my bookmarks down, get a LastPass, and I'm literally back to where I left off in Chrome. And then any projects I wanted to pick back up from, I just go clone them back down from GitHub as I need them.
I've had an instance where I've used the clone, Git clone before, and I've downloaded it to a site. And then there's other cases where I've gone to the website and then I download the entire repository as a copy.
Yeah.
And then you install it. But there was something one time when I unpacked it and I tried to run something. I guess it was some alteration in the file that was downloaded and unpacked versus the one that was cloned and run. So it would, if you cloned it, it would run. But if you copied it and tried to do something, it didn't. And there was a Git command that you could use to fix it. I don't know. I'm not recalling what it was.
Yeah, I'm not familiar with that very scenario. That particular scenario. It sounds logical that there would be a state where something gets zipped wrong, but I wouldn't know. But this all leads to a term you've probably heard 1,000 times, and if you're in this talk, you might never ever participated in, called the pull request. So all a pull request is a fancy way of saying we're going to do a branch to make our changes that we want to make. And then we're going to have a discussion of whether those should be merged or not. And the person who finally gets to make the call is the owner of the repository you're trying to merge it into. So if you find the Git repo for Git, you could say, I want to make these changes. And Junio, to this day, is the guy who says, yes, I'm the person who will make those changes happen. So what you end up doing is for using the GUI tool of GitHub. This is the only way I'm going to talk about it. There's a lot of ways to get this done, but this is the fastest. I've made my code changes in the GUI IDE that comes with GitHub. It's like, all right, let's imagine it's an inline comment change. Like, hey, I have terribly used bad grammar in this inline comment. So we're gonna make this inline comment change really quick. I don't need to do a bunch of stuff fancy. I'm gonna just edit it here in line, and then instead of, if I owned this, so I can just put it right on my master branch. But let's say I didn't own it. If I didn't own it, this goes away, and all I get is this: create a new branch for this commit, start a pull request. So on GitHub, I guess that's all I got. On GitHub, a new branch appears It lets the owner know that, hey, someone has done work against this repository, and they want you to put this change into master. And here it's sitting in this branch for you to look at. So I can go look at that branch, clone it locally, or copy it locally, and then like test it out. It's like, yeah, I like that change. Let's go ahead and let's run with that. Go back into the interface and say, all right, let's merge that in to master. And that pull request will be accepted. So it's a very fast way to like, I'm gonna make this change, push you the change, let you review it, and then merge it in as you see fit. This is how teams work. So this is everything I memorized. Like all that stuff about merging and pull requests, if you're working with a team that is relying on you to do pull requests, they should be able to teach you how their system works and who you need to alert, if you need to alert anybody, what they want their commit messages to look like, and they'll work with you on that. This is what I memorized out of Git, what I know in my fingers. And I know these in my fingers very well because I use them a lot. If we go back to what I said very, very, very early on, Git's for knowledge workers. It's not for code. It just works exceptionally well for code and projects. How I learned Git was through content. Just making stuff and version controlling it over time. So this is the repo for a little GitHub project that I got going, but if I change to my public folder, change to notes. Nope. So this is a folder of all the WordCamps and Drupal camps I've been to since the beginning of 2017, all the notes I've taken, and all the blogs I've written out of it. So I could do a Git log and see back to the beginning of the repo what I did when I added what. And do a full-on Git log. Git. I can say, all right, here's where I added my talk about Baltimore. That was on Sunday the 7th. That was also where I added my notes. On the 2nd, the Drupal corn notes, because I went to Drupal corn. And these are very lightweight notes. This is a public repo. You can go look at this yourself if you want. For my private writings, it's actually way more useful because I'll put in like notes in my comments of like where I got the idea to say what I was saying, to what I'm referencing or what I was thinking that day. So I have this like meta information around my personal writings. That's, I think, the fastest way to learn is just start editing text files. That's all it is. For everything else in the entire world, there's the internet. And again, this is the most heavily documented thing I've ever seen. I highly recommend, personally, DuckDuckGo. Not for the privacy, not for the speed, not for any of the layout stuff. Actually, it is for the layout stuff. Because they started doing this about a year ago, maybe a little longer. If there's actual documentation for the thing you're looking up, it just displays that documentation. That's a good DuckDuckGo really cool thing. Versus Google, which will tend to send you Stack Overflow from 2014. Nothing wrong with that. Git hasn't changed. But this is just a little faster if you're looking up specific commands. There's even a couple of resources, like at the very bottom, like how to fix things. Greg Anderson's favorite website is this one, actually, Oh Shit Git, which is how to unstick yourself if you've stuck yourself in a bad situation in Git. And ultimately, if you're doing things correctly, and you've gotten things pushed to, like, I got this commit and pushed up to my GitHub account, or my GitLab account, or Bitbucket account, and I know that reality is good, and I'm working locally, and I have completely destroyed the folder through some terrible series of decisions. We are RM minus RF, like the wrong folders, and they're just gone, man. Well, we can just change directory up, remove the folder, clone back down, and we're right back to where we left off, no matter what we did to that folder. There's a lot of resources. GitHub itself, if you're like, this seems really overwhelming, I'd like someone to walk me through one command at a time and let me practice this in a free, awesome environment. It's called Learn Git. LearnGit.com. GitHub set this up for us to use. Oh, I'm sorry, that's Git Tower. No, it's Learn Git. No, I'm sorry. Try it at GitHub. No, where is it? I had it bookmarked. Then I just deleted all those bookmarks. Is it try Git? Let's try Git. Try. All right. I shouldn't have unbookmarked it. And I didn't reference it in these slides. All right. Well, you'll find there's a lot of tutorials. That's what I should have looked up. Git tutorial.
Try to github.io maybe?
Yeah, Git tutorial. Huh. Maybe they took it off. There used to be a really cool tutorial, but there's a ton of tutorials. There's a ton of videos. Is this the one? Did they rebrand it? All right. Sorry. I can't find it now. But there are a lot of tutorials out there. There are a lot of people that can walk you through things, and here are links to them, and cheat sheets, all sorts of cheat sheets. When I first was learning it, I had printed one of the PDFs out and had it by my desk and helped figure stuff out. This point where
It might be called Get It,
Get It.
Git-IT. Because they're having a hackathon right now, and they, or if you put Hacktoberfest, it has information on learning, their latest info on learning Git.
I was just learning Git.io or .com.
But that's the one that has the bot that checks your work.
Yeah, that's the one I'm.
I think it might be Get It, but I know you can find it if you go to Hacktoberfest right now because they're promoting it.
Oktoberfest. Get hosted. Flux.
Somewhere in there, because I was doing it last week.
This is the GitHub Learning Lab?
Back in the day, it was just called Try Git, but now not.
Well,
Oh.
Get It is a desktop app that's supposed to be available.
Nah.
Sorry, I need to send you
Well, Codecademy has this course. Maybe they just merged it with this. Yeah. Codecademy has a free course on Git that takes you through everything I just took you through, except for pull requests. And it's free.
Oh, they have.
All right. Well, we're at overtime. So, thank you very much, everybody.
Is there any limitations to the file types or anything like that?
No, it works absolutely best with text files, but it doesn't matter what kind of text file. Like a JS file is as good as a markdown file, as good as anything else.
It'll do this, but for image